The broadcast is now starting. All attendees are in listen-only.
Okay, everybody. So we're going to kick this off. Perhaps more people will join us along the way. My name is Roy Baron. I'm a channel sales manager at Redis Labs. Adi, you want to quickly introduce yourself?
Sure. I'm Adi Folger, Principal Architect for Redis Labs.
And thanks for joining us, everybody. Again, good morning and good afternoon, wherever you may be across the US. We wanted to do this presentation, which was successfully organized by DataFactZ, which is a partnership for Redis Labs, which has been growing recently, and we really appreciate their help with putting this together. For those of you either new to DataFactZ or just started working with them, they offer B2B services in three main practices: data engineering, data science, and big data as well. And really, Redis and Redis Enterprise, as you guys will better understand on the presentation, is a great fit to DataFactZ's business. And that's what led them to this partnership with Redis Labs. And we see a great fit here going forward. And this presentation will be about introducing Redis Labs. We'll start with a quick introduction to our company, Redis Labs, and where we kind of fit in the NoSQL market. Then we'll explain a little bit about what Redis is, and later down the presentation, also what are the advantages of Redis Enterprise. We'll also explain why Redis is a great fit for some of your big data scenarios and should be your first database of choice when it comes to solving complex application data-driven use cases with NoSQL solutions. All right, so let's kick it off. Adi, could you just quickly flip slides?
Hang on. There we go.
Thank you. So who are we? Redis is the leading and most popular NoSQL in-memory data store in the market today. We also call it a data structure store. Once Adi takes over, you guys will get a better feel of why we also call it a data structure store. I'll leave that to Adi to explain. Redis is a great fit for high-performance operational analytics or hybrid use cases. Now, I want you guys to keep in mind before we dig deeper into this presentation, most people, I wouldn't say most people, a lot of people today really know Redis as a caching solution. Initially, it did start as a caching solution, but just keep in mind that over 60% of our customers today are actually using Redis as a full database. And you'll understand better why when, again, after Adi digs deeper into Redis and Redis Enterprise. Now, Redis Labs, our company, offers two products. One is open source Redis, which we are the company behind. Our employees contribute over 90% of the code to Redis open source today. And a cool fact for you guys, the creator of Redis is actually employed by Redis Labs, leading our open source practices and initiatives, and also helping us to grow this great Redis community. Now, I want to show you guys just how popular Redis is today and how big this community is. And I want to show you a few slides around that. Adi, could you just turn to the next slide? Thank you. This is Stack Overflow's most recent survey. For those of you not familiar with Stack Overflow, it is the biggest and most trusted online developers community in the world today. And they actually published their biggest survey to date, which they did with over 100,000 developers worldwide. And for a second consecutive year, Redis was voted the most loved database and the database they mostly want to continue developing with. Next slide, please. Another slide I wanted to show you guys here. This is StackShare's top 10 data store ranking. You can see that Redis is just behind MySQL, which is actually a relational database. And according to their ranking, it is the #1 NoSQL database in the market today. Next slide. Another one which I wanted to bring to your attention is DB Engine's database popularity ranking. You can see that DB Engines actually checked over 340 databases to create this ranking. And this is actually really up to date from the beginning of May. And you can see that Redis is in number 7, just trailing behind MongoDB, and the number 2 NoSQL database according to their ranking. Now, I want you guys to keep in mind that all the database vendors that you see ahead of Redis have actually been in the market far longer than Redis and Redis Labs. And Redis has been by far the fastest growing database since January 2013, and we're going to see it keep on climbing up the ladder. And we're definitely going to pass MongoDB eventually and become the most popular NoSQL database in the world, and hopefully the most popular database overall one day. Next slide, please. Just a few more popularity rankings I wanted to show you guys. I'm not going to tire you with all of them. We don't have time for that as well, but just some notable ones from this slide. As you can see, according to Sumo Logic, Redis is the number 1 NoSQL database on AWS today. Also, it is the number 1 database and most loved and most downloaded on Docker today. You can see that there have been over 600 million downloads to date on Docker. We see about 1 million downloads a day, which is just crazy. And actually, the second vendor trailing behind Redis and Redis Enterprise is far behind, with somewhere between 80 to 100 million downloads thus far. And this all ties to the technology shift that we're seeing today towards microservices. And Redis is a really great fit when it comes to developing applications in a microservices environment. Last thing I wanted to show you guys from this slide, I wanted to mention actually, is StackShare's top 50 developer tools ranking. And they recently published their 50 top developer tools, and Redis was actually the first database to ever make it to their top 10 list. And this just comes to show how popular Redis is today amongst application developers out there. Next slide, please. So this is actually connecting now to Redis Enterprise, which is our second offering. Redis Labs is really growing with Redis Enterprise. We have over 8,000 customers worldwide. We're managing over 550,000 databases today. Some of our customers include 6 of the Fortune 10 companies, 3 of the top 4 credit card issuers, 3 of the top 5 communication companies, and 3 of the top 5 healthcare companies. And we're going to see that list. Growing, and it's already actually growing on a weekly basis. We're going to see a lot more customers growing with the popularity of Redis. Next slide, please. So this is actually some of the verticals that I'd say the main verticals that Redis Labs is in today. You can see some of the great logos that are customers of Redis Labs. At the end of the day, I want you guys to remember, Redis Labs is not limited to any vertical really. It all comes down to the use case. With the built-in data structures and modules, which Adi will soon elaborate on, you can really extend Redis to almost any use case and to really any vertical out there today. Next slide, please. Next slide I wanted to show you guys. So this is the current Redis Labs IaaS and PaaS ecosystem. As you can see, Redis Enterprise supports all of the popular public clouds today. And on the PaaS side, I think two notable big partners of Redis Labs today are Pivotal, which is by far our biggest partner to date. This partnership mainly revolves on the integration between Redis Enterprise and Pivotal Cloud Foundry. So you could easily add Redis Enterprise to the PCF platform and then seamlessly spin up scalable and highly available Redis Enterprise clusters. Another area which we're seeing this partnership currently grow in is Pivotal's initiatives around microservices, and as you can see, Pivotal Container Services, or PKS. And this is based on the integration between Redis Enterprise and Kubernetes. For those of you not familiar with Kubernetes, it is a container orchestration platform. And you could today easily connect Redis Enterprise to the Kubernetes ecosystem and then orchestrate your Redis Enterprise environment via Kubernetes. And this ties back to the popularity of Redis on Docker today and that whole shift that we discussed earlier towards microservices. So we're going to see a lot of business and opportunities coming from that area of the partnership as well. Another partnership and last one I wanted to mention here is our growing partnership with Red Hat OpenShift. We were actually just a few weeks back at the Red Hat Summit. We had a booth there. We presented, and it was a big thing for our company because we recently became a certified partner on Red Hat OpenShift. And again, this partnership also revolves around the integration between Redis Enterprise and Kubernetes, which I explained earlier. And we're going to see this partnership growing rapidly, again, due to that shift that we're seeing towards microservices. And I just want you guys to keep that in mind in terms of which IaaS and PaaS vendors Redis Labs works with, which really extends our offering and makes it easy for our customers. Next slide, please. So before I hand it off to Adi, just wanted to show you guys the current deployment options that you have with Redis Enterprise. We're really agnostic. Before I go into more details, we're really agnostic to any deployment option out there today. We make it very flexible and very easy for our customers. So we have three flavors, if you will. One is our cloud offering, which is a fully managed solution where we're basically hosting your Redis environment on our Redis Labs infrastructure on any of the popular public clouds and your region of choice. The second one is our VPC offering, which is also a fully managed database as a service in your own VPC on any of the popular public clouds. So essentially, the customer will either give us access to their VPC or we will set up what is called a VPC peering. And the customer will tell us what kind of Redis environment or Redis Enterprise environment they want in place. We'll help them to set it up and we'll manage everything after that on our side. But this all has to do with the customer's own virtual private cloud environment on any public cloud today. Last one I wanted to mention here is our software offering, so or Redis Pack, we also call it. Now, in this case, we basically give the customer the Redis Enterprise software, where they could deploy it in any of the deployment of their choice. It could be on any cloud, in their own on-prem, in their own private data center, in containers, virtual machines. They really have the flexibility here to deploy it anywhere. And what typically what we do is our team helps the customers in this case to set up the Redis Enterprise environment. And after that, we expect them to fully manage it themselves, of course, with the full support of the Redis Labs team as needed. And as you guys probably noticed, the VPC and software offering are both on RAM or Flash. So for those of you not familiar with Redis, Redis is typically served from RAM or from memory, which really what gives it its great performance, as Adi will further explain. But with VPC and software, we also support Redis Enterprise on Flash, which is a great fit for those really large data set use cases where Flash is essentially an extender to RAM. So you get the same Redis Enterprise performance like you would on RAM, the same speed, but with a major infrastructure cost savings, which could even go up to 70% in certain use cases. And Adi will further elaborate on that as well. So at this point, I'll hand it off to Adi. I appreciate you guys listening. One thing I failed to mention in the beginning, if anybody wants to submit any questions on the control panel, there is a question section. So feel free to submit any questions you might have, and we will do our best to address them towards the end. If we don't have time, we will return the answer via email after this call. We know who asked the question. We could tie it to the attendee afterwards. So feel free to submit any questions if you have any. Thanks, guys.
Cool. So essentially, there's three major pillars or ways to think about Redis in terms of what makes it different and from other databases and other technologies out there. First and foremost, what normally people associate with Redis is going to be speed. And then secondly, it's flexibility or ease of use. Redis is, like Roy mentioned, usually running 100% in memory. And because of the way that you interface with it, you're essentially using the same kinds of variables or same kinds of data structures that you would have in your code. So it's operating at a lower level of abstraction than any other data platform out there. And then taking that same concept, you can actually bucket together and different data primitives and different logical operations around that to create your own data structures in the same way that you would with classes in your code or essentially like plugins. And that gives a lot of extensibility. And I want to talk a lot more about that here in just a second. So just to give you a sense of what I mean when I say performance. So on the left there, we have what is the highest throughput at the lowest latency possible. And this is actually a little bit out of date. We can actually perform even better than this now. So it's over there on the left three, you can see Couchbase, Cassandra, DataStax. They're all operating at under 10,000 operations a second, and they're running at about a third to a quarter of a second of latency versus what we have, where we can do over 30,000 operations a second with only 70 milliseconds of latency. And actually, in some of our latest benchmarks, you can get over 10 million operations a second with a millisecond or less of latency due to a lot of improvements that have been made since this benchmark was done. And then on the right side is something that was done by Google. It's particularly interesting because they went out to the world and said, hey, what is the minimum footprint that you need to be able to deliver 1 million writes a second? And so each company had the opportunity to put their best foot forward and show what the infrastructure cost of that was going to be. So Cassandra came back with 300 servers, Couchbase came back with 50, and then we came back with 2. And obviously that's exponentially cheaper than any of those other options, and then something that you can also run on commodity hardware to get the kind of enterprise grade performance that is required by very, very large organizations. As I mentioned, each of these different data structures is available as a primitive within Redis. You can use it to build out various different kinds of functionality. Most commonly, we're talking about either data denormalization or caching using strings or hashes. Hashes, if you're using Java, are essentially key value maps from dictionaries in Python. There's a lot of different words for that concept, but that's probably the core available in terms of creating either logical objects or just various ways of compartmentalizing your data. And then what essentially happens is, in the same way that your code, in your code you provide meaning to what's going on by using variable naming conventions. So, you don't want to name something too short or too long. Your key names in Redis provide a notion of meaning to the data based on the way that you organize and structure it. So you can see here, we have a date and then a time. And so it's using that to denote a bucket of data using the sorted set, which is a collection of unique strings with a numerical score associated with them. And then being able to do that, we can do essentially a query to show what is the highest bid in the auction. So the bids themselves are what these scores are. And then for some other kind of pointer denoting the information about who the bidder is. And there's all kinds of different ways that you can take this using various different concatenations. So your indexing essentially shows up as a part of your key naming structure. So you can see here, we're wanting to search on date and time. So that's what I mean by indexing. You have the ability to search key names within the key space. And there's just a lot of flexibility that builds, because you have, like I said, all these same things in your code, and you can imagine all the different pieces of functionality that you can write in your code. You can now expand that horizontally and have your services operating in a stateless way, and using Redis as the main state container. You're able to then build out this essentially shared memory platform for your overall architecture. And that's what big companies like MasterCard, Visa, American Express, et cetera, go in and use us for, is to be able to provide these high scale throughput operational databases, which then either push information into their analytics platform or are receiving information from their analytics platform to power things like fraud detection, customer onboarding experiences, so on and so forth. So I'm going to get into a little bit more detail about what that looks like architecturally later on. But just so you kind of get a sense of what is possible from all of this. This is the very important basic building blocks, and you know, the graphics that we choose here are very, very intentional of every single piece of Redis code out there. So going off of that same idea, here's a collection of different use cases that empowers us to be able to participate in. And then with the addition of modules, a lot of these things are essentially more and more turnkey every day. So historically, as Roy mentioned, Redis was used primarily for caching, and up until probably about 2013, 2014, that was really the only use case that I think people trusted with it. But more and more, 70%, as Roy said, are using it as an operational database because of the flexibility here. And the way that I've always kind of talked about that, having used Redis now for about 5 or 6 years, is the last 20% is going to require a fair bit of work client side. And then with modules, we now have the ability to go in and extend upon functionality that exists in Redis core, and do things like stored procedures, like triggers. And so, for example, especially in the machine learning space, this is particularly interesting because A, it enables us to integrate with other technologies like Spark, which I'll talk about in a little bit in a minute here. And as well, it allows you to build out probabilistic or machine learning data structures in Redis. So we have, for example, a native neural net module that allows you to build and train neural nets inside of Redis. We have Top-K and Bloom filters, which allow you to do very, very quick operations in terms of filtering. And there was actually a talk at RedisConf a few weeks back that was talking about using Bloom filters as identity checking in adware. Is one of many, many other options that are available out there. So this core idea that I was talking about, this Redis memory as a service, is what's represented here at the bottom of this diagram. And each one of these is essentially a Redis process. So Redis being single-threaded, the way that you want to scale that is usually vertically on a node in order to take advantage of the resources available to you on the VM. Cloud providers such as Amazon or Google or what have you, people only generally use about 70% of the resources that they buy from the public cloud. So Redis Labs started as a database as a service company, and part of our business model in doing that was making sure that we weren't going to be wasting 30% of the resources that we were acquiring from these cloud providers that we were hosting our service on. So what we did is figured out a way to wrap the Redis operations with various complementary pieces of software to either create a better dynamic when it comes to scale, so allowing you to use multiple Redises to back up a single database, as well as HA, allowing it to be very seamless from the application's perspective. But like I mentioned before, once you start pushing to be using maybe 90% or 95% of the VM resources available to you, that's going to create volatility in the machine. And so we don't necessarily want to, compromise quality of service or have any kind of downtime associated with that just because we're trying to maximize our ROI on the investment that we're getting from the VM purchases. So the cluster manager component is essentially keeping that from blowing up. And if there are issues with the VMs, which it's much easier to plan for things to fail and then figure out how to recover them than to assume that they're not going to, right? So in that scenario, the cluster manager component will recover things. And that's just one of the three kind of core pieces of this wrapper that I've been talking about. The other part is going to be a proxy component. If there's a secret sauce to what we do or something that really, really makes our technology special, I would say that it's this proxy component. It's really neat in the sense that it allows you to be able to use 1 or 100 or 1,000 Redises that make up an individual database. From your application's perspective, it's completely opaque. There's just one endpoint that you're hitting, and then the proxy components combined with our routing architecture will make sure that you are being routed as close to that master as possible in order to minimize the latency involved in terms of secondary hops. It's also going to be there in case that master goes down and you need to fail over to a slave. It's going to redirect you that way rather than your application having to essentially internalize this change of state and having to respond accordingly. And that just ultimately improves the recovery time of failure events and improves overall uptime of the application. And this same approach as well has made sure that we haven't lost anyone's data. It's also allowed us to reach a ridiculous level of scale in our own internal operations with minimal HR costs. So and what I mean by that is we have 500 million databases that we manage in our public cloud, Redis cloud offering. We have a team of about 4 to 6 people who manage that using this software. And it's the same software across the various different products that Roy talked about. It's a shared nothing architecture. It allows you to be able to build out clusters into the number of hundreds of nodes. And with that, you were able to reach some pretty cool numbers of scale, such as hundreds of terabytes running all in memory. There's also, like Roy mentioned, a flash component, which I'll get into a little bit more detail here in a minute. And then on the performance side, like I mentioned before, we're now reaching tens of millions of operations with a millisecond or so of latency. And all of that comes from being able to scale up in this way. The module components that I mentioned before, these are a selection of the ones that we are supporting at an enterprise grade at this point. Modules have been in Redis now for about maybe a year, 2 years or so. And we took Redis from having 9 data structures to having over 60 in just that short period of time. Historically, Salvatore, the main author behind Redis, has been very stingy about adding what could be seen as superfluous code to the Redis core. And so it was very difficult for even his colleagues here at Redis Labs to be able to contribute to add new features without it being a very, very lengthy review process. So the module concept was really born as a way for us to be able to scale out his abilities, scale out functionality in the Redis core product, and also be able to, in that 20% that I mentioned where it's a lot more difficult, to be able to do things with Redis to actually kind of bridge that gap of what has been historically filled by the open source community in terms of libraries, or by individual developers and writing it into their own client-side code. Redis Search is a full-text search engine. It's currently 5x faster than Elasticsearch, scaling up to billions of documents. It's all using that same Redis core technology, so that's where a lot of the speed is coming from. But essentially what we're able to do now is using the same enterprise technology that provides you the scale, HA, and flexibility, you're also now able to get the same, that same scale with search, with this performance that you can see on the screen. Redis-ML is an integration with Spark, and essentially, it's not, Redis-ML is specific to Spark, but the way that Redis can be used in big data platforms specifically is not tied to using Spark as the main analytics engine. This ML module makes it easier to pull data in and out, and it is definitely the most recommended way that we have. But essentially what it allows you to be able to do is build out these operations or this kind of data architecture. And so the main way that it ends up being used is as the serving layer. And what Redis-ML really allows for is the serving of models that are built out in the Spark layer and the data science component. But as well, and this is where I think the Flash side of things becomes particularly interesting. Most of the time when we're talking about data warehousing, we're not talking about just a single one-way flow of information. Unless we're really talking about BI tooling, but that's very seldom the case. And then even in that case, you also have the flow back of information from, say, management to make decisions at the company based on what the BI tooling is set. So point being, you always are going to need to pull data out of your platform in order to be able to run analytics on it. And for example, one of the things that I did when I was running media stuff through at NBCU was tracking our view data using Redis and being able to plot that on a map, as well as aggregate it for later on doing analytics and things like that. And the way that that was implemented was doing a very, very simple just tossing of it into Redis, which has a very low latency, so therefore very low impact on your production application. So over here, you have your production application on this side, on the left side of this diagram, and then we would have Redis coming in as definitely as the acquisition and potentially as your processing and governance layers as well, depending on exactly what that means to your company. And then again, on the serving side, because of the low latency, because of the high throughput scenarios that I've mentioned before, it becomes a very natural selection for something like a data mart or a back-end data service that's going to provide these insights that your big data platform is being able to create. And then kind of pairing off of that, once we start talking about more than a terabyte of memory, usually IT managers' eyes get a little big because they start doing that linear math operation in their head of, oh, I have to buy this many chips of RAM, and it just becomes generally a little bit more difficult for them to wrap their heads around. So especially once we start talking about that amount of data, you're not really necessarily needing super, super blazing fast performance. Or even if you are, you're only going to need that for some top N% of that data at any given time. At no point, no customer that I've ever worked with is working with all hundreds of terabytes of data or their whole petabytes of data at any given time. They're always working with, generally an operating set of about 100 gigs to a terabyte at most. And so what Redis on Flash allows you to be able to do is use the Flash, specifically NVMe drives, as a way of extending the RAM without having a significant extension of cost in terms of infrastructure. But more importantly, what I think that is interesting, especially when I'm talking to people who build data pipelines and things like that, is you can end up with 7, 8 different pieces of technology in an overall data pipeline just to be able to create the level of scale that something as simple as Redis on Flash can do. And when we start removing pieces of technology, I find that, myself personally, when I was doing a lot more of the development facing side, the best days were when I could delete a lot of lines of code and simplify things for the project, rather than welding in new ideas or coming in with, a completely new piece of technology in order to solve the problem. And so the more simple your architecture, generally the more simple it is to scale. And that's really where, when we start talking to companies like Charles Schwab or MasterCard, that really was part of their decision-making process in selecting Redis to be the backbone of various different applications that they have. And really, just some numbers to kind of back up what I was just saying. It's significantly cheaper, 80% or a little over 80% cheaper for you to run using Flash versus RAM. This is probably going to be pretty obvious to anyone who's ever had to buy computing hardware before, but just so you have it, those numbers are there. And then lastly, I want to talk about what we do in active or global data scenarios. It's based on what are called conflict resolution data types. And what those are is a group of mathematicians got together one night and tried to figure out how can you solve data conflict problems without having 100,000 or multi-million-dollar atomic clocks in every single data center. If we could all accurately predict time down to below the nanosecond level, then I think a lot of these problems go away, but we can't genuinely do that. So these guys figured out various different strategies to be able to deal with these conflicts. And essentially what we've done is take those same strategies and then looked at the various methods that exist in Redis and tied those different methods or those different data structures to which conflict resolution strategy makes the most sense. And as we've continued to develop all of this, one of the things that we do very well at Redis Labs is bringing in the expertise that we need in order to be able to scale and build high quality products. So for example, Salvatore is being a member of our staff and making sure that what we do with Redis Core and Redis Open Source is at the top-notch grade that it needs to be. We also have one of the main mathematicians behind this as a member of our board of directors. So we've actually gone in and expanded upon this conflict resolution data type or data modeling kind of exercise that they started and started to invent some of our own based on also, obviously he's providing us guidance. But the newer versions of our products are going to have even more sophisticated ways of resolving these conflicts across geographies. So some examples of what I mean by that, sets are a collection of unique strings. There's a lot of math pieces behind it that allow them to be very useful for doing analytics on large collections of unique items. And essentially, I'm sure many of you are already familiar with these, but we want to be able to go in and never look at an absolute value of the set at any given time. Sets have tools called unions, intersects, and differences that allow you to be able to see how they change over time or how they overlap with various other sets. So here in this example, we have A being added on the West Coast and B being added on the East Coast. So then when finally they sync back, we have both A and B. And the way that that's being resolved behind the scenes is via a union. So we're pulling in the data from both sides and making sure that we have all of them at any given time. Similarly, if we were to remove, we would look at a difference, right? And figure out what is there on one side that shouldn't be. And these different per method levels, you can see these sadd commands being used or the srem command being used to remove are how those different conflict resolution strategies are being triggered. Another example is the accounting. So here we're going to look at the deltas at any given time rather than look at the absolute value again. So here we've done add 1 to K1, add 1 to K1 in Europe, add 1 to K1 in the US. So eventually, once they sync, they should be 3 on both sides. But what's happening here is we're sending +1 to Europe, we're sending +1 to the US, and then we're sending +1 to Europe again, which is how that's being managed, rather than, like I said, looking at the absolute value at any given time and having to figure out what was the last right wins, which is generally the way that most database providers out there manage this kind of problem. So with that, we can go ahead and get into some questions. Oh, doesn't look like there are any.
Adi, it's Roy. I have a question for you. Do you mind just clarifying for our audience here, in terms of the bottom line, what kind of use cases they should be looking for, what kind of things they should be aware of when dealing with those Redis use cases, and really what is the bottom line added value that Redis Enterprise brings to the table?
Really, it's economies of scale. When it comes to using Redis, it's a very straightforward and easy thing to get spun up. Where people start to struggle is when they start needing to scale that. So, like you mentioned, we are the most loved database according to Stack Overflow. Developers feel that way because of the ease of use, because of the flexibility of options, because of how many different use cases we can fill, everything from caching to producer-consumer queuing, state machines, operational data, to full-fledged, providing kinds of relationships through naming conventions, so on and so forth. But I think historically, for myself and many other people who've used Redis extensively, there was always in the back of our minds, well, at some point, if I get, a lot of scale or, a lot of users, or my data gets really complicated, I'll need to go in and move it out to, a more sophisticated database, quote unquote. But I think as time has gone on with the addition of modules, with the work that we've done in terms of being able to provide the scaling layers with Redis, especially the companies that we work with are beginning to realize that they don't really need anything more than what they have with us. And if they do, it's usually for something very, very niche, like big data processing with Spark, or significant complex relationships that might require something like a graph database, although we do have a graph module as well. And so especially when I start talking to like companies that provide online dating or airlines, things that have very broad and somewhat disparate data structures or data behind their operations, those situations can be a little bit more counterintuitive. So not only do we provide the scaling layer, but we also provide essentially trusted advisors that can come into your account and look at what you're trying to do and help to coach you to build things out in a way that will scale and a way that will essentially be a lot more fault tolerant. And I think probably the real big piece that's somewhat new is the global side of things. So for many of the data platforms that you mentioned, or not data platforms, but platform as a service technologies out there like Kubernetes and PCS and stuff like that, we generally are the ones who are able to connect multiple foundations or multiple Kubernetes deployments and provide essentially that unified memory layer that you're getting for all of your horizontally scaled services to be horizontally scaled globally without necessarily providing an incredibly increased latency cost, which is usually associated with the hub and spoke model that most database providers that are out there would require for that kind of deployment model. I think that answers your question. Is there anything you want me to go into more detail about?
Yeah, that was perfect. One more thing I just wanted you to clarify. Can you clarify the bottom line added value of our active-active geo-distribution feature? What is the added value, and what what it really simplifies for our customers?
So I think in terms of numbers, it's going to reduce overall development time and design time. And the reason why is there is somewhat of an inflection point as you're scaling where you start to realize that you need to exist on a global stage. And that could be just because you have a certain number of customers, or more usually you have a very broadly distributed group of customers, and you want to provide better quality of service by placing more regionally local deployments of your application. And when you do that, especially if we're talking about things like banking or any other situation where if there's little changes in the amount of data or in the specific data points that the end user is seeing, like the classic example that we talk about is when I'm going from, if I'm talking to my wife on the West Coast and I'm on the East Coast, we should both see the same balance on our online banking account. And we can't have any kind of variance in that regard. So in order to create that unified or consistent platform, you really need the right kind of tools to be able to do that. And I think what we do with CRDB is the most sophisticated way of approaching it out there on the market today. Pretty much everyone else, like I needing very, very precise time synchronization, and then there's still a pretty large room or pretty wide margin of error that can exist in that way, or you're going to end up with significantly slower response times as a result, just due to the overall need to be able to create a lot more insurance or a lot more assurance around the way that that data is being shown or distributed across the system. So with what we do, it becomes less something that has to be thought about from the developer's perspective. Overall, the architecture, once you kind of decided that this is what you want to do, it's something that you can lean on, and it's on a per operation basis. It's fairly easy for developers to express the intent that they have for that data by selecting the correct method for what it is that they want to do. And so as you get used to that, it becomes less and less around solving big problems, big architectural problems, and more solving the day-to-day problems, which you can trust maybe a more junior developer to be able to do. Therefore, your more valuable senior developers are able to focus and move on to, the next big project, while the more junior guys are able to continue to develop on, and you still get that kind of peace of mind that your overall data platform is going to remain consistent and meet the design standards that you had at the beginning.
That was perfect, Adi. Thank you very much. Guys, so Adi, I think we can end the session here. I just wanted to thank everybody for joining this morning or this afternoon, again, wherever you may be. I hope this was helpful for you guys. Going forward, we're going to follow up with an email, and we're going to share the recording with you guys. If there's anybody that wants to have a deeper conversation with us about some of the Redis or NoSQL use cases that you recently ran into or intend to try to solve very soon, or your team just started to work on, we're happy to have a deeper conversation which will include the DataFactZ team, and feel free to reach out. Thanks, everybody. Have a great rest of the week.
Thanks, Joe. Take care.